Good afternoon, folks. We are in lab number 8. This lab has two parts. This lab is on curve fitting. In the first part, we are going to fit a linearized curve. And then in the second part, we are going to fit a non-linear curve. I think this is going to be one of the most useful labs. I hope it is going to serve you throughout your curriculum. So even if your instructor does not require it this particular way, you can always test out different curves on your data. Your data may be from your project or from your labs. So here is stress strain data. It is shown in 4 columns, but basically it is 2-column data. We want to fit this polynomial stress versus strain. So it has got 3 terms and therefore 3 unknown constants, C1 through C3. Our first function is 1, second function is x or strain, and third function is x square or strain square. So I had asked you to prepare a lab template. Here is our 8A lab template. So please type in the data from the previous slide. And just as a check, whenever you have a lot of data, what you might like to do is when you're transcribing from one place to another, you might like to use this checksum idea. So what I've done is I have summed up all the values in column A, and they sum up to 0.03283. Similarly, all the values in column B, they sum up to 271,000. So this way you can ensure that your input data is correct. Okay, so let's start by naming matrices. So our column B, this matrix, we are going to name it Y. C6 through E18, this 3-column matrix, we'll call F. And this 3 by 1 unknown coefficient matrix, we'll call it CC. The reason we can't call it C is because C is reserved name for columns. Okay, we have formats, X values 5 decimal digits. Our Y values 0 correct decimal digits. Okay, and so on and so forth, you will see. Okay, so we did this checksum already. Now we are going to set up our function matrix equal to 1. This is equal to X. And this is equal to X square. So 3 functions, we typed in 3 formulas. So now we are going to copy formulas only. We don't want to copy these borders, etc. So we'll say copy. And we are going to copy it all the way down. So we are going to paste formula only. Okay. So let's check our formatting. So 0 here. F2 and F3, we want scientific 2 decimal digits. Okay, when we come to Y and C matrix, we will come back to this slide. Okay, so we have done this step. Now let's calculate our C. So our C matrix is, we are going to type in this formula, equal to M mult of M inverse of M mult of transpose of F by F comma emerged of transpose of F by Y. Control Shift Enter. Great. So now we want C matrix scientific 3 decimal digits, which is what we got. Y values as 0 decimal digits. So let's see our Y value formula. So our Y value formula F6 through F18 is this M mult. Remember, this was our first slide when we did matrix formulation of our problem statement. F times C was Y. So we are going to say equal to M mult F comma CC, Control Shift Enter. So we have our Y values. Now let's check and plot these. So we are going to plot X, Y, and we are going to select big Y. Okay. So I'm going to maximize my screen. So we want to do insert and we want dot and smooth curves. So now we are going to modify the chart. So we are going to move the chart first to a new sheet. Okay. So let's start by moving our legend up somewhere here where we can see. So this is our smooth curve. We don't want any markers, so let's format. Let's see. So we don't want any markers. And for this is our data point, blue. We don't want any line. Okay, so we have data and fitted curve. Okay, now let's look at our axes. So axis seems to have 2 extra zeros. So let's format that. Format axes. So we want 3 places only. Okay, this looks all right to me. And now let's start giving our titles. So chart title, stress strain, linearized curve. Okay. Horizontal, we have strain in inch per inch. All right, let's do vertical. So that is stress in PSI. That's pretty much it. Let's move it back to object in linearized and we'll drag it to the bottom. Okay, we are all set. Let's go ahead and check our print settings. Print, page tab, sheet, grid lines, row column headings, Everything fits nicely in a page, so we say okay. So let's save as Lab 8. Okay. All right. Second part of the lab. In the second part of the lab, we want to fit a non-linear curve. So we want to fit this surge curve, which has a power component to it, curve component to it, and an exponential curve component to it. So here we have the data from, you may remember I did an example, percent water in cement and its strength, compressive strength. So first and third column are percent water, and second and fourth column are compressive strength. So again, let's start with a template. So we have this template. Here is the data from the previous slide. Again, use a checksum. Make sure that your checksum matches mine. Okay, so when we did linearization, so look up the last lecture on curve fitting, and we have done surge curve there. So we need these formulas. So let's go take a look at that. Oh, before we take a look at formulas, let's name cells. Now, cell C, we have already used the name Y. So I'm going to name this YY. Okay, we have all the function matrix, 3 by 1, 3 by whatever, 3 columns. We have already used name F, so we are going to name this FF. Okay. So we can't use names K1, K2, K3 because they represent cells. So we are going to name these K_1, K_2, and K_3. Okay. All right. We're going to check the formats later on, but they are listed here. So we have done checksum 58.25 and 103,800. Let's start typing in formulas. So this is log of V. This is equal to 1. This is equal to log of U. And this is equal to minus U. Again, we are going to take all these formulas, copy, formulas only. Okay. Now we are going to type the same formula we did for linearized curve because we just linearized it here. So our C1, C2, C3 will be M mult of N inverse of M mult of transpose of FF by FF, comma, matrix multiply transpose of FF by YY. Okay, Control Shift Enter. Okay, so we fitted the linear curve. Now we are going to transform C's into K. So this is exponential. K1 is exponential of C1. K2 is same as C2. K3 is same as C3. Okay. So our curve is K1 times U to the power K2 times exponential of minus K3 times U. So we'll take this, copy, formula only to all those. Okay. Make sure we have our formats. Let's go check formats. U 3 decimal digits. 3 decimal digits. Okay. 3 decimal digits. Should be 2, but this says 3. V0, C through F, 3 digits. G0, all C and K values, 5 decimal digits. Except K1, which we make it, you can see it'll become very large. 0 decimal digits. Okay. So everything matches. Let's draw our curves. So UV, this is our data. Control key, I'm going to select column G. And insert, same thing, move the chart. Okay, let's do our curve. Again, pink curve. We don't want any markers. Blue curve is our data. So we don't want any line. Let's move the legend up somewhere here. Happened here. Okay. Let's go ahead and adjust our axes. We seem to have too many zeros out there. So 0 decimal places. And now we just add our chart titles. So this is percent water versus cement strength, surge curve. Okay. Axis title, horizontal is percent water. Y-axis vertical is compressive strength in PSI. And that's about it. Keep it simple. And we move this back. Move chart, object in nonlinear. And we'll drag this down right below. Okay. Looks pretty good. And let's go ahead and make sure we have our print settings. So I gotta get out of my chart mode, print. Okay, so we have grid lines, we have row numbers, everything fits nicely in a page. We do save. Okay, folks, so it is our grading rubric. So please check all your formatting, print setting for each sheet. Make sure it fits on one page, grid line, row column headers, and file name is Lab8 and submit it to my courses. I just want to point out that make sure that your workbook works upon opening. Otherwise, I will not give you more than 50% of the grade. Take care.